Oh no.
Oh no.
Oh no.
Oh no.
Episode 2.
Episode 2. What's going on?
I have no idea.
How are you?
I'm doing great. It's
Great.
Friday, apparently.
It is. Apparently today it's spooky day in the office, but yesterday
Spooky
was
day?
actually spooky day.
Who people dressed up as grapes?
Yeah. Yeah, I saw one of the recruiters just running around with a bunch of balloons on him.
She's in meetings in the grapes.
Yeah. Oh, are they all the recruiters
Yeah.
in grapes?
Yeah.
That's just not comfortable.
I don't know. It's dedication, I think.
Yeah.
Yeah, it's good.
Gotta applaud them for that.
Good. So, episode 2.
Yes. What did we do
2.
last time?
Last time we talked about variables. We talked about if statements. And we looked at scope.
We had homework.
We had homework.
We want to talk about homework?
We'll go into that.
Okay. Cool.
So
what are we doing today?
Today we're going to start to look at functions.
Functions.
So last season we talked about these, like the basic blocks. Like you need data somewhere. You need to be able to ask the questions of data, and then you need to be able to abstract code, the storing of data and asking of questions. You need to be able to abstract that away and then reuse that, and that's the function. So last season we kind of did that all in one swoop. I thought this season let's split it apart. Let's do variables and conditions first, and then we do functions on their own. So that's the thing we're doing today. And we'll actually kind of start on our little game that we're making, or game system thing. So there will be a thing we're going to be programming there. So that'll be interesting.
Sounds good.
So we move over to the presentation.
We should. There we go.
There we go. Well, why are you making a face?
I'm not making a face.
You're not making a face?
Nope, I'm just hanging out.
I just wanted to say hi, Gabe.
Okay, hi.
Hi. How are you?
I'm pretty good.
You're pretty good?
Yeah.
I love cringe.
Hate you.
Let's sit on it a little bit. Like, yeah.
Okay, yeah, that's good.
Yeah,
Here,
it's
rub
good.
it in.
Mm-hmm.
Right there.
There we go. A little bit more? No.
Yeah.
So last week we went over a few fundamentals, like we talked about. And this week we will focus more on functions, like I said in the intro. So last week was let's store data, ask questions. This week, let's package that. Because programming is basically storing data and asking questions, either one question or loop at a time, and then putting it into a function. That's what's going on. So that's a quick intro. But this is a new thing, since homework is a new part of the season. Let's review homework.
Ooh, wait, well, I didn't save anything though.
No, this is more going to be of a chat. No. You didn't,
God.
Your dog ate your homework?
My computer ate my homework. I don't have anything.
No, it's more of a chat. So let's go over. In this case, there isn't a solution. Next week, or basically the homework for this week, there is a solution. So I would expect you to bring stuff. Yes.
Oh.
It's not this week. That's why I didn't mention it. We talked about that we want to create variables using all the types. Did that go okay? Like,
yeah.
Was there a type you couldn't make a variable out of?
No. I was able to use them all.
You use them all? Were you able to use void?
I mean, I didn't try to use void.
You didn't try to use
no,
void?
because I rewatched the episode and it said, we'll get to that later. So I was like, okay.
Okay, yeah.
I didn't try void.
No, because you can't.
Okay.
You can't make a variable of the type void.
Okay.
Like strict void.
Oh.
You can...
I used int, bool, and char. Or car, or whatever.
Yeah, char.
Whatever it was.
Then we wanted to try changing the values, trying to break them. Was there anything interesting there that you found out?
Didn't really break anything.
No?
Found out that everything has a number.
Everything is a number?
Yeah. So
even Boolean?
Yeah.
Yeah.
0 and 1.
0 and 1.
Well, I remember that. I remember that a little bit from season 1.
Mm-hmm.
So when one of the things says like, can you plus different variables together? I just plus 2 different bool values together.
Yeah.
And I got 1. And I was like, why do I have 1?
Yeah, exactly.
But then I remember that false holds a value, which is 0, and true holds a value, which is 1.
Yeah. And you were talking to me when you were doing the homework, and from how you were talking to me, you were inspecting them. You were putting a breakpoint.
Yeah.
Because one question you had, like, oh, I'm getting garbage.
Yeah, because I didn't have the break. Is it called breakpoints?
Yeah, breakpoint.
I didn't have the breakpoints at the end of the brackets.
Yeah.
I just had it on that, and I forgot that you need to have it after the brackets because it's running everything that's before it up to that point.
Yeah. So the breakpoints run are before the actual line is run. So could you assign variables as different type to each other?
Yes.
Could you plus an int and a bool?
Yes.
Yeah. So that was
It was just a number.
It's just a number. Yeah. And yeah, can you plus together the variables as different types? Exactly. You had one thing where you were adding together two chars, adding like a B and a J together, and you were like, that doesn't work.
Yeah, because it was Batman against Joker.
Yeah, he had a kind of he named all the variables after Batman or DC hero characters.
Well, it was just Batman.
Yeah, Batman.
Just kept calling him Batman.
Yeah, sure. I mean, they could be called whatever. And you had a char called Batman, I think, and then another one called Joker, and they stored B and J.
Yeah.
And then you were plussing them together, and that kind of didn't work.
No.
Or not as a char.
No.
And why was that?
Well, I know why that was, because you told me afterwards why that was.
Because you were like, that's weird. That doesn't work.
Because ASCII characters only go up to when they're...
It's 128.
Yeah, 128 or 255 if you use the other version.
Yeah, they can go up to 255. And if you plus together B and J, that's a number that's just bigger than 128. So that doesn't work. Regarding conditions and scopes, is there anything you could you ask a question?
Scopes were kind of finicky. You have to put them in the right spot. If
yeah.
they're not in the right spot, it just goes, Yeah. You get some error.
Could you ask questions of all the types?
Like if statements to questions? Yeah.
Yeah.
I did some if. I did a lot of health-based things. Like if you have this or if alive, do this.
Exactly. Could you ask of different questions? Could you say like if an int is bigger than a bool or something like that? Could you change the types?
Oh, I didn't try that.
No, that's okay.
I'm guessing you could.
Yeah, you can.
Because it's just basically asking.
It's just a number. Again.
Are if statements always like greater or less than?
Greater than, less than, or equal.
Okay.
Yeah.
Okay.
Or not equal.
So yeah, then you could do that because it would just be like asking
numbers.
Is this number bigger than this one?
Yeah. If Joker is bigger than Batman, exactly.
Joker actually killed Batman in my scenario.
Yeah.
Yeah.
There you go.
Because the ASCII characters added up to less than 100.
Yeah. Exactly.
So he died.
Yeah.
Rip Batman.
Could you put scopes anywhere?
No.
No. Where couldn't you?
Anywhere that didn't seem right. That's the kind of the answer. I don't know. I tried just putting a scope in the middle of like just a thing. It just went, I don't know what this is.
So scope kind of has to be kind of inside of another scope. You can't put it in an if. Yeah. You can't put it in the main. I
put it right after the greater than symbol, and it just went.
Yeah, it doesn't work. Can scopes be inside other scopes?
They can if they're scoped. I don't know what the term is.
Yes.
Scoped properly. Like if I have an if statement, I can put a scope inside that, and then a scope inside that, and a
exactly.
Scope inside that.
So you can just make infinite scopes.
Yeah.
And the if is a scope by itself.
Yeah.
So
you could just keep asking scope if
exactly.
if, and you'll get some really specific situation.
Exactly. So you can kind of think of that you have a scope, which is the open curly and the closed curly, but then you have a conditional scope, which is an open closed curly with an if at the top. And now we're going to look at functions, which are basically, it's a scope that is only executed when you call the function. So it's like, if is a scope, you only go in the scope if the if is true. A function, you can think of that as a scope, it's just somewhere else, and you only go there if you call the function. So it's a way of thinking of that. So, functions. Let's talk about that a little bit. Today's episode...
Wait, did I pass my homework?
Yes, sir, you did.
Yay!
So, today, it's not as much as slides. We're going to be playing around in Visual Studio a bit more, a little bit more chatty and play around. And then there's homework at the end there. So, a function is a way to reuse code. That is kind of a simplest way to think about a function. So, functions have a name, they have a return type, and they optionally have an input argument. And they kind of then look like this. You have a type, which is one of the fundamental types we're talking about. You have a name, which it basically has the same naming rules as variables. So it can't be...
What's an example of one we did in processing?
What do you mean?
Would it be like add?
Add?
Add is a function?
Add is a function, yes.
Okay.
And we're going to create a few of them, yeah.
You can create functions?
Yes. You can make you can make your own. And we're going to be doing that. So you can they can't start with a number, but they can have a number in it. They can have underscore. They can't have a dash. Yeah, so there's some rules, and you can see it's the scope, and then there's some code within it.
That's how you do it.
That's how you do it. So they can also then look like this. If it's with some arguments, it returns some type. It has some name, and then it can take in 1, 2, 3, 4, whatever, many arguments. I don't think there's a limit, maybe in the hundreds, but I don't know. You shouldn't be doing that, basically. It would be annoying to use. So an example, like you said, add. Here I am creating a function called add. And what is the return type of this one?
Result.
The type of it.
Oh, int?
Int, yes.
Yes.
So the name of it is add. It takes in 2 numbers, which are of the type...
Number A and...
Yeah.
Or the ints.
Yeah, the 2 ints.
Yeah. With the name number A and number B.
Yeah. And then on line 3, after the scope, there's nothing magical about functions. They're just, you can have any code there as you want. You can create variables, you can ask questions, you can do whatever you want. Here I'm just creating a variable called result. I'm storing in it number A plus number B. But then if you want the value that was computed within the function out, you have to return it.
When you return it, does that mean if A is 1 and B is 2, then it's returning 3 to add?
Or it's returning 3.
What stores the number 3 then?
Yes, that is a good question.
Oh.
Yes, so that's the next part.
Okay.
So, and again, you can also have, like here I have a function with the type int. You can have a function with the type void as the return value.
Oh no.
That just means that you don't return a value from it. You can return from the function, but you can't, like here, I'm returning something, return result. Here, I can do code, I can have ifs, I can create functions, or I can create variables, but I can't say return something, because this says it returns nothing. So there's no return from it.
But that's because of the void?
Yes.
Okay.
Yeah.
So what's the point of a void if it doesn't do anything?
That's a great question. That is a great question. We'll come to that. We'll actually use those later on.
Oh no.
But yeah, it's a good observation, because you have a function, it does something, it takes some values in, right? But it doesn't return anything. That's like putting stuff in a box and then expecting stuff to come out the box after it's been doing its thing. But this one says you can put stuff in the box and then nothing happens.
Someone, Mohammed in chat, is asking, is this necessary to return value from function every time, I assume? I'm not sure if that's a question.
In a function that returns a type, like this one, int, you have to always return something. There are languages where you can say this function returns a value, but sometimes it doesn't. In C++, you must always return a value of the same type that is in the return. So here you must always return an int. And if you would, in line 3, instead of saying int result, you would say char result is number A plus number B, and then you would say return result. Then result is of type char. Yeah. It's not the same as int, but what will happen is it will convert it over to an int.
Okay. I was going to say, is it going to convert the add?
But
it converts the result.
Yes, because it's of a different type. And sometimes that's not good, and the compiler will warn you about that, because let's say that you want to return a char for some reason, and you do some work, you want to return a char, but you give it an int in the return value. What happens is the compiler will warn you and say, int is actually a bigger thing than a char. So you're saying, I want to return something that can hold a very big value, like 4 billion, but char can only return a value of up to 128. So what happens when you give it the number 1000? It doesn't work.
Yeah. So
the compiler will warn you about that. Yeah, the function type and the attribute type should be the same. There is a catch to this, but I'm not going to go into that. As with the language, there's a bunch of catches, but we want to focus on the simplicity here. Yeah, so you can have void functions, and we'll go into those a bit later. So, like you talked about, so this is the add function from before, from line 1 to 6. is the same. And then we have our main, which is, as you can see, a function. So main is a function, but there's one thing magical about it. It acts like a function, it works like a function, there's nothing different about it except one thing. You as a programmer, don't call main. Main is called by something else. You could think of it as it's called by the operating system, or it's called automatically, or whatever. So main is called for you, if you think of it that way. So the program will actually start in main, and then, so if this is an application that we wrote, and we make an executable out of it, the first line of code that's actually executed is line 10. Yes.
What's the reason it's in that order then?
It can be in any order.
Yeah.
You can mix the orders around. It's just, it will find the main function and then say, let's start from there. And we will actually play a little bit with this today, is to play with how the program jumps around. Because we will go into main, we will do some work, and then we can see that the breakpoints, they go all over the place. So here, we start in line 10, and we want to create a variable called sum. But the value of sum is the result of the add function. So this is the same as season 1 with processing. You call add, so we then have to go into that function. We do the work that's in add. We go to line 3, line 5, we return the result. And then the result from add is put into sum. So here, it's 5 and 10. So 5 is put into number A, 10 is put into number B. So 5 is in line 10, goes up line 1.
So when you create a function like add,
yeah,
add will be a unique name to that function specifically.
Yes.
So if this is called banana,
yep,
and I write int sum add, it's not going to know where banana is, or it's not going to know where add is because we called the other one banana.
Yeah.
So every time you want to create a function later on, you just replace int number A and int number B with the values you want. If you put, so it's always add brackets two numbers.
So it's always function name, brackets, and the argument you want to put into it.
Okay.
Yeah.
But the arguments are set on the first add, isn't it?
The arguments are set by the function. So in line 1, you're saying, I'm a function called add.
Yeah, and add stores number A and number B.
Yeah, we only take 2 arguments.
Okay, so you couldn't, for example, have add 5, 10, 15, 20, 25.
Correct.
Okay.
Correct. In this setup, no, you couldn't. Yeah. So add is called. We go in. Number A is 5. Number B is 10. We say that result is number A plus number B. 5 plus 10, it's 15. So result is actually then 15. We return result. So add is basically a way of saying this is the number 15. And then we say...
And then when it's doing int sum, it's just...
We're creating a variable called sum.
Yeah.
And then we say the value of sum is the result of calling add. Cool. So, there's an important point here. The input arguments in a function, it only exists in the scope of the function. So if I go back, we have number A and number B.
Yeah.
Those are variables, just like result is and just like sum is, but they don't get their value by someone saying number A is equal to whatever. They get their value from the outside, from someone calling the function and giving it. And just like result in line 3, when the scope of the function, the scope is from line 2 and 6, when that scope is out, not only is result gone, but number A and number B also doesn't exist anymore.
So you couldn't even do it.
What do you mean? So this works.
Yeah.
But number A, number B, and result only exist as a variable
within them.
Within the add scope. And when add is done, they are deleted. They're gone.
Bye.
They're bye-bye. So the input arguments, which is in the previous slide, input number A and number B, they only exist when the function is being executed. And we'll see this, we'll play around with this. And they are separate variables from the ones you send in. So I sent in 5 and 10. if I would have sent in a variable instead of 5 and 10, if I would have sent in Batman or whatever.
We should send in Batman.
We should send in Batman. Batman is one variable, and it's not the same variable as the one in the function, even though they might have the same name and even though they might have the same value. They just have a copy of the value. You're basically copying the values. Yeah, so they are separate from the ones you sent in. So here's an example more closely to what we want to do. So in main, I create a variable called health, and I create a variable called damage. So I have 100 health, and someone is doing 10 damage to me. And then I create a function called do damage. We would like to do damage. It takes in 2 variables as arguments. They are also called health and damage.
But they are set the health before.
Yeah, but they are not. If my mouse works, this health here is the same as this health here. Yeah. But this health here is not.
No, because it exists within the scope.
Yeah, this one only exists within this scope here. Yeah. This one only exists within this scope here. So what's happening is when I send in this variable, in here, I'm just copying the number 100 into this variable here. So it's just a copy. Okay, so should we play around with this? So let's swap over to our Visual Studio.
Double coding or just you?
We can do double coding.
That's double webcam.
That's double webcam. There we go.
Well, it's a double, okay.
Let me see. Isn't it like var in scopes? Yeah. So with a scope, you can only see your scope and down. If you think of it that way, you can't see. Like if I create an if here, this is a Swedish keyboard, there we go. Here's an if scope. And if I create health here, let's call it 100, and I have some, or just have scope here. If I have, for example, damage here, this damage sees this health. So they can kind of work with each other. But if it's a function, they can't interact in that way. So damage can use, I can say damage is equal to health. I can say health is minus equal to damage. So I can play with both of them. So they can go up and down. But if it's a function scope, they can't interact. And we can see that in a bit. But so let's create add in the beginning. So let's start with that one. So if we go up here to the top, I'm gonna make it a little bit bigger. So we create a function here above main. Yeah. So we want to add 2 numbers together like I did in the slides. So the return type of add would be int because we want the number back. We want to call the function add, and it takes in 2 numbers.
Well, my keyboard was also Swedish.
Yeah. So let's call that number underscore a and comma int number underscore b. And then I create my scope. So here I have my little function. Let me shrink it down a little bit. There you go. And then we want to add those 2 numbers together. So I say, let's call that result. And result is equal to number a is plus number b. Yeah. And then I return result. Yes. So let's here in main create a variable called sum. Sum is equal to add, and let's do it like the slides. It's add 5 and 10, and then we return sum. Okay, so here's the pop quiz. If I put a breakpoint, I think yours is the same. If I put it on 10, if I put the breakpoint on 3, on 5, and then on 12, what is the order you think of the breakpoints that will happen first?
10. 3,
Yeah.
5,
Yeah.
12.
Yep. Exactly. So let's try that. If we hit save and hit F5, we should get our nice little view. So if I mouse down a little bit, yep, exactly. 10 is first. And if I go to my locals and see that not only, I don't know how well it's visible, but sum is here.
Should be visible on the full video.
Yeah.
It's just hard for us to see on the little preview
We have a little
screen
preview thing. So sum is here, but it has junk as a value. So that's not good.
Junk value.
Yeah, because it is whatever memory was there before. Because we haven't called the add function yet. We don't know what the result is. So if we hit F5 and go up.
Now it knows number A and B are 5 and 10.
Yeah, look at this. So in line 3, we already know A and B. They're 5 and 10 because that's the one we sent in from here.
But wouldn't it be... Oh, so it would... Does it go from 10, then it does 1, 2, and 3?
Yeah.
Okay.
Yeah. So it's 10 up to 1, 2, and 3, 5, 6, and then 10, 11, 12. Or 11, 12.
Isn't that inefficient?
No.
Really?
This is actually pretty fast.
It sounds like it's jumping around without any reason.
So jumping around a lot can be inefficient. What the compiler can do is it can take this code over here and just copy it down here.
Okay.
So for you have this nice abstraction, you have the function that does the work for you, but the compiler can find out that, oh, I can actually put this stuff here. So, but it can be, if you're always jumping around, yes, that can be inefficient. So we have 5 and 10 in A and B. We can even like mouse over it here. But we don't have result yet. Like before, result is some junk value. If we hit F5 again, now we should have
it. 15.
It's 15. And if we hit F5 again,
15.
We have 15.
Sum is 15.
Now sum is 15. And number A, number B, and result, they're gone.
Dead.
They are dead. So, and the same thing here. If we can put if statements here.
What'd you do? Oh.
We can say if result is bigger than 10, then we might do result is equal to result plus 1, something like that.
Done. Oops, I forgot my brackets.
Yes, it is okay. You can declare a function first and then you can define it. So this is called defining a function. You can also declare a function. You don't have to mimic this. This is it from chat. You can say int add, int number A, int number B, and then hit semicolon. So here you've told the compiler there's going to be a function called add. I'm just letting you know. I haven't made it yet, but this is how it's going to look like.
Here it is.
Here it is. And then later on in the application, you can say ... and then here you make it. And that's fine. You can do that. And that's a way. What you can do is, if I take this function here, if I cut it out and put it under main, now this works because you're saying, hey, I want to call a function called add. How does it look like? Oh, it looks like this. So here's the add, but it's actually created over here. So if I delete this guy, it's going to complain. Should complain. It doesn't complain, but yeah,
No.
It generally will complain. Anyway. So yeah.
We're using Visual Studio 2019, the Community Edition.
Yep. So here I can make a result, which is adding two numbers together. I ask a question of it. So I can do an if and a scope inside a function. That's fine. I ask it if it's bigger than 10. I do some work. I add one more to it, and then I return it. So if we now go and add a couple of breakpoints here, just liberally spread them around.
Should we just go to your coding? You want to show this?
We can just have it like this. It's okay. It's going to be short. So if I run this, we'll first start in the sum. Maybe drag it down a little bit here. Then I go up. I have number A and number B. Result is still junk. I hit F10. Now result has a value. The value is 15. I'm asking a question, is it bigger than 10? Yep, 15 is bigger than 10. I go in here. It's still 15 because I haven't executed this. go in. Now it's 16. And can go one more. You see, we're still alive. Everything is still fine.
Still alive.
Still alive. We have number A and B, and then
Gone.
they're gone. And now we have some back.
Dead.
So some didn't. So I can show you maybe another quirk if I do this. So let's say that I create sum here. Sum is equal to number 5. Okay? And then I say sum is equal to sum plus the result from add. Right? So first I created sum. It has the value 5. And then sum is going to be whatever sum was before plus whatever the result of adding 5 and 10 together is. I can skip this just to simplify things. I want to notice a thing here. Oops. I run this. So sum is junk. I hit F5. Sum is number 5. So we haven't actually run this yet, like before. I go in here. We have number A, number B, result, whatever. Now when I come back out, it's not like, because we don't see sum here, right? Sum isn't here. When we come back, it's not like it's going to forget what sum was, because this depends on that sum is actually 5 before. So if I go back here, sum is now 20, which means it kept whatever value was here. So even though it looks like it's going away, it's still there. It's just not within this local setup. So that still works. All right. So for our game, we would like to do a function that will do damage, right? So let's create that one. Because if we want to create some sort of turn-based RPG thing, it's my turn. I have a character. It has health.
I hit you with stick.
I hit you with stick. So if I'm hitting you with a stick, you have a certain amount of life. My stick does a certain amount of damage. I want to hit you. So, and we can think of that action, the doing of the damage, as a thing we very commonly do. It's a common action. Yeah, it's happening every round, right?
Hit you with a stick.
Hit you with a stick. Or hit you with an amazing sword of plus whatever. Yeah, we would like to use a function that does that for us, because we don't want to write that code again and again and again. So let's write that function. Let's write a function that does the damage, right? So if I clean out the add function we had, and we can clean out main a little bit. So if we imagine that we have health, like we talked about last episode, let's say that we have 100 health. And let's say that the weapon of the enemy does, I don't know, 4 damage. So, yeah. So let's call that enemy damage. Damage of the enemy is 4, right? We can even think of it as, let's say that we create, let's call it player health. It's called player health, and then player damage. And we also have, no, we're stronger than them. We have 8 damage.
Bam.
Yeah. So we can then also say that we have enemy health.
And they're weak.
They're weak. What do they have?
50 health.
50 health. And they do 50 damage. They do 4 damage.
Oh my god, don't do 50 damage.
Do 50 damage. 1 shot.
2 shots.
Yeah. So we've stored our health in an integer. We've stored our damage in an integer. The enemy health and the enemy damage as well. So we would like a way for someone to do damage to us. So what we could do is we could just, you don't have to follow along here. We could just say like player health is equal to player health minus enemy damage. Let me shrink that a little bit. Here we go. Right? But there's a problem here, right? So player health is equal to player health minus enemy damage. So we write minus the damage, and the enemy health is equal to enemy health minus player damage, right? This seems logical, right?
Is the issue that it's all in the same thing?
So
I feel like there's not an ordering issue, but it's gonna take the wrong values somewhere.
well, so player health is 100,
Yeah.
and there's nothing else changing that. Enemy damage is 4, so it's 100 minus 4.
But is it because they're named the same thing?
Well, there is one problem here, which is this is kind of the same code. This is the same thing. There's another problem is, what if the scenario isn't that we have 100 health and enemy's doing 4 damage? Let's say that we have 3 health. We're almost dying.
Negative.
Yes, there we go. So we'll go into negative health. We don't want that. So we need to do some check to say like, hey, if we went to negative health, dead, yes, and
make
then
dead
make
is alive
dead.
false.
Is alive false, yeah. So should we have a boolean here as well?
Probably.
Yeah, let's do that. So player alive. Maybe that's true. And then we have a bool enemy alive. It's also true. So they're both alive.
But then down below, or no, do we put the if statement below that line then?
Yeah. So if we ask a question.
Try add this stuff. Try add this.
Yeah. Yeah. Let's add that. That's okay. So while you're typing, so if the player health is less than 0, we can have a scope here. That then means that player alive is false. We're dead. But we also might want to do that the player health is 0. Because we might not want to show minus numbers in our thing. You're typing away.
Slow typer.
It's okay.
Oh, wait.
You did Heath again. It's okay, you can copy paste that. Yeah. And then you can see that you can actually just copy that, replace that underneath, but swap the values. So instead of saying player health,
Enemy.
you have enemy health. So this is a nice way also, if you click on it, you see all the locations it's at. So it's here, and it's here. And then we don't want enemy health minus enemy damage. We want to do player damage. So it's enemy damage. And we don't want to do player alive. It is enemy alive. There you go. Again, you see, this is the same code, right?
Yeah.
It's doing the same thing. And this is why functions are so powerful, is here we have this happening. Like, this code is okay. It's only one round. We want to do more rounds later on, but this is fine for now. So we want to take this code and put it in a function. So let's do that. So what should we call this function?
I don't know. Make damage.
Make damage.
Make attack. Maybe just call it attack.
Attack? Yeah.
Seems like a safe.
So we're going to make it return int, and I'll show you why in a bit. So let's call that attack. And we open. And what are the common variables that are going on here?
Player health or player damage.
So player health, so it's some sort of health value and some sort of damage value.
Yeah.
Okay? So we can say, let's just call it health and damage. We can then think of it is implied that the damage is being done to this health. So we could have a feature where you can do self-damage. So we have this function. It's attack. Let's just copy this in, these lines here, and put them in there. But it's going to complain, right? And why is it complaining? Let's mouse over.
These?
Yeah. If you mouse over it, and just wait a second.
It's undefined.
So player health is undefined. Which one is defined? What variable is defined?
Health.
Health.
And damage.
Yeah, so let's replace that. So it's health instead of player health. So replace that. And then it's happy. Well, it's not. Sorry, it was this one. And then you have again here, identifier enemy damage is undefined because we call it
I
damage.
cheated. I skipped ahead.
It's okay. But we have a problem here with alive, right? Let's skip that one for now, for a little bit. So we just delete that one.
Okay.
Just for now.
Skip it.
Does C++ have reference in and out? Yes, but I'm avoiding that for now. I'm avoiding it for now. So we take in some sort of health. We take in some sort of damage. Health is equal to health minus damage. If health is negative, we set health to 0. Let's then do a thing where we return health.
Oh, whoops. Got to...
Yeah. So we return health.
Oh my god. Oh my god.
Because what we want to do is, we want the function to be, it's called a pure function. So if you look at the function here, there is nothing from the outside that is influencing it. And this function isn't modifying anything that isn't within the function. Everything that it's modifying, it is something that exists within the function. There's no outside forces that are happening here. And that's called a pure function. It only works with the data that's within it. So we have attack. Great. Can't we then say that instead of saying player health is all of this stuff over here, we can say that player health is equal to attack of player health and enemy damage. So there was an attack happening. And what was under attack is the health of the player, and what was attacking is the damage of the enemy. And since we return the value back out, right? Might zoom out a little bit, thank you. It's okay. So there's an attack happening. The attack is happening on the player health. The enemy damage is doing the attacking. And since we return the health out after we've modified it, we modified it here by taking the damage. We also modified it here to check if it was less than 0, and then we return it out.
I'm completely lost.
It's okay. So let's do the same thing for enemy health. So we have enemy health is equal to attack of enemy health and player damage. And we can actually delete the last part here. Great. So what's going on then here is, or let's just break into it. So if I put a breakpoint here in 22 or around that point, yep, and let's run this and see what happens. So here in the locals, we have enemy alive is true, enemy damage is 4, enemy health is 50, player is alive, player damage is 8, and player health is 100. So here we have the attack function. Let's go into that one.
But so it's okay. So it's again starting with main.
Mm-hmm.
So it's starting by reading main.
Mm-hmm.
Oh my god, close. How do I go back? Okay. So starting by reading main, and
yep.
That's where it got all this information.
Yeah.
But the moment it reads player health,
mm-hmm.
What is telling it that it needs to go up here then?
It is because player health is a variable. It's
because of the attack.
Yeah. So we say the player health is gonna be equal to
attack, and then it goes, wait a minute, where's that? And then it goes and finds it.
It goes and finds it. It's up here.
Okay.
So we send in player health and enemy damage. That means that health here is gonna be player health.
Yeah.
Damage here is gonna be enemy damage.
Yeah.
So it's gonna be 100 and then 8 up here. And the first time we call it, we will do this. We can look at that in a bit. Then when this is done, it has modified health.
Yeah.
Because we sent it in here. So let us put a breakpoint here at the top on line 3. And so you can run it. I'm going to hit F5 again. So I'm now in the attack function. Yeah.
Mine went real simple.
So if you try it again, if you close it, and then one more time F5. Yes, there you go. That's it.
Okay.
No, you're in autos if you go to locals.
I don't even have locals anymore.
Did you delete it?
Probably. How do I get it back?
If you go to view, there should be, or is it in? No, sorry, it's debug, Windows, and you have locals about halfway down. There we go. That's okay.
Oops.
It's okay. So now we are in the attack function.
Yeah.
And what is our input? It's health,
Yeah.
which was 100, which
Minus
was from
the damage.
And then we have 4 as a damage. So it's health is equal to health minus damage. So if we go in that means that health is now 96. You didn't put another breakpoint.
Well, oops.
Yeah. If you just run, no, you have to close it now and run it again. This is, yeah.
There, got it.
So now health is 96. Yep. Damage is still 4 because we don't modify damage. We're asking a question, is health less than 0?
Yeah, but it's not.
It's not.
So it'll skip that.
Skip that.
We can return it health.
It would return health, yeah.
Which is why we have 96 now.
So we have 96 in the health variable, which means that when the function is done, and we're back to line 23, we're going to say that attack, this function here, gave us the value 96. So player health is going to be 96. So if we hit F5, we see that enemy health is 50, player health is 96. So there was an attack on player health given enemy damage. This was the code that did it. This is also why you saw, because you hit F5 twice, and it stayed in the function. Yeah. Because now the enemy is going to take damage.
Yeah.
But it's the same function, you see. It's the same code base. It's an absolute reuse. But now what is under attack is the enemy health. What it's doing the attacking, it's the player damage. So now if we hit F5 again, we'll go back up.
Yeah.
Health, which was before 100, because it's, if you think of it as now as it's another function call. It's not the same function call, but it's the same code base. So health is now 50, damage is 8. We say that health is equal to health minus damage.
Oof,
so health is
42,
now 40, messing them up. It's not smaller than 0. It's great. We return out, and then you might do this because your program exits because you didn't have a breakpoint after that, but I can fix it. Here we go. Enemy health is 42, and player health is 96.
Bam, we're winning.
We're winning.
Yeah, there will be VODs of the stream for those of you watching the VOD, obviously.
So here we have created some data that meant something, but it meant something to us. For the computer, it's just here's two numbers and a boolean, but it means something to us. And here we have a function. We're reusing it, calling it twice. We're doing some work in the function. Here we're reducing the health based on the damage, asking if the health is less than 0. If it is, health is 0, and then we return it back out. And then we assign that then to the player health and enemy health. So we took damage. We didn't use the boolean. Some might say that it's not actually use. It's not. If you want to ask a question, is the player alive? Now, you wouldn't actually need the boolean, right? Because you can just say, because health will always be 0 when you're dead, you can then just ask the question, is health equal to 0?
Would you ask that within the if? Or after the... Or...
You could do it here, but it might not mean much. You could do it here. You can say, if player health is equal to 0, then player alive is false. Because there was an attack, something happened, some damage was taken. After the attack, the line after, we ask a question, is player health 0? If it is, yeah, the player is no longer alive.
Dead.
He is dead. And we can do the same thing if you want for here, but just use enemy health and enemy alive. There we go. Again, I would think it's a little bit cleaner. And if you think of this function, it doesn't care what kind of health is being sent in, and it doesn't care what kind of damage is being sent in. It works either way. So I could do damage to myself. I could be doing damage to a lot of things.
Don't do damage to yourself.
I won't. So, yes. So this is it for the episode like that. I'm going to show you some homework. It's a little bit different from the one before. And in this one, you don't have to, if you're watching, you don't have to submit it to us. You can have a chat about it on Discord. That would be lovely.
We have a Code School channel on our Discord.
A lot of people there asking questions. We also have a programming channel on Discord.
In the VOD, you'll see it in the link in the description.
Mm-hmm.
For those of you in chat, you can type !Discord.
Yep.
Or in the description somewhere below as well.
So please join that. There's a lot of lovely individuals there are asking questions, and not only about C++ or Code School. There's all sorts of questions going on.
Like, how do I kill Uber Elder?
Yes, video games are fun. So let's go to my full screen, and I'll show you the homework. So homework. So there's homework is split into two. These are more for you to play around, have fun. Like last episode, there isn't a result here. This is more of a play around with it, try to break it, see what works, what doesn't. So can you use all types as arguments in a function? All the fundamental types we've been talking about. Also, can you...
Arguments is what's in the brackets.
Yes.
Yeah, just to
Yeah.
make sure my brain works.
It's okay. Can you use all the types as return values? That's the first one in a function.
Return bool.
Can you return a bool? Can you return a char? Can you return a float, etc.? Can you return a void? That's another question. Can you create scopes within functions? We kind of showed that, but please play around with that. Can you create a function within a function? That's a question.
Well, I don't even know what that would look like.
Yeah, that's a question. Can a function call itself?
Probably.
Probably.
Maybe not.
Maybe.
I don't know.
Huh? That's a fun one. What do you think happens if it works?
The world explodes.
World explodes. All right, great. So these are the more to play around with. If you want a fun screenshot, there we go. And here's the more homework. So there's 3. They're increasing in difficulty. So first one is write a function that takes in 2 integers and returns the one that is bigger. So you can give it A and B or whatever you can call them, and the return is the one integer that is bigger than the other. So if A is bigger than B, you return A. If B is bigger than A, you return B. All right? Okay. Write a function that takes in a character, one character, and returns true, Boolean, if that character is lowercase. So you send it in one single character, it returns a bool.
So the function would just be like name, and then in bracket it would just be char.
You can, yeah. So it would be bool is lowercase and then char and then something. You would ask the question if it's lowercase.
Okay, yeah. No, I meant in the actual first line of the function.
Yeah.
Itself.
It would be bool. That would be bool and then is lowercase and then char and you can then say character or whatever. So that's the header.
That.
That's fine.
Okay.
And you can Google the ASCII table to do that. And then the last one, write a function that takes in a character and makes the character uppercase, but only if it was lowercase to begin with. So you can then use the function from before in the second example to solve the third one.
Oh, I'm completely screwed.
Mm-hmm.
Yeah.
Fun times. So that's it for today. Next week, more fun. I think next week we'll be looking into loops and might look a little bit into classes. So that'll be a fun one. And then, what was it, the week after that? Where we might have a break?
Maybe.
Yeah.
We'll see.
We'll talk about that next week. Yeah. So do your homework. Practice. This episode is not, like, watching it and not doing work is okay, but you'll do, like, these 2 things, the homework here, these 2. This is the work. This is what will give you the most value. Me talking and you watching is like 10-20% of the journey. So thank you very much, and we'll see you next week.
Yeah.
Bye.
Bye.